What's up, skater boys and skater girls? Guess what we're doing today? Maybe I'll give you another tip. Look at this. That's right. I bought a pair of skateboards for me and my girlfriend, so we get out a little more. You know, get rid of that nerd tan. And we have a small flat, so these skateboards would be in the way everywhere. So I designed and printed two holders for them. And today's episode will be about those. But that's not everything. I also show you how to put a camera mount on these skateboards to drive around with your action cam. Stay tuned. Alright, we're in our favorite editing tool, OpenSCAD, and I'll just walk you through the process of designing a board holder. Basically, that's what I'll call it. I'll give it a nice name as a comment in the top. The dimensions that I plan on maybe changing in the future is the thickness of the board. I measured mine, it's 17 millimeters. And the width of the holder, I'll leave at 3 centimeters for now, 30 millimeters. All the other dimensions will be dictated by the number of screws and the angle of the cavity that will produce for the skateboard to wedge it in. What I usually do is I know I'll be designing a simple cube and I'll just cut out the cavity for the skateboard to wedge in and also some screw holes, and that's it. So we'll start with the cube. We want it to have width of 3 centimeters. We'll make it 5 centimeters deep and 8 centimeters high. We hit F5 and then we already get the preview. Now what we want is we want to cut out the skateboard, as I told you already. Therefore I measured it and it's approximately 50 centimeters long, 15 centimeters wide, and has a thickness of 1.7 centimeters. Now for visualizing this, since we are subtracting this cube from the first cube, we won't see it except where it cuts out. So for visualizing the whole thing, we can just put this hashtag in front of it, hit F5, and then we get it rendered as a transparent red cube. Now we want to translate this cube to the position where we want this cavity to be cut out. So now we have these numbers, and as you can see, this would already make a pretty nice holder. I can disable the visualization now and we see the cutout and how this part would look like. But that's not what I have in mind. I also want this cavity to point slightly upwards, like 20 degrees. That's it, so it'll be held down by gravity if I wedge it in there. And this already looks pretty nice. Now all that's left to do is just cut out the holes for the screws. We'll use 2 bigger holes for a screwdriver. And we'll start by defining a cylinder with a radius of 8 millimeters, let's say. Give it a height of 100 and use 32 sides. Again, we make it visible. It's oriented this way. We just rotate it around the x-axis. Bang, now it lies flat. And we can see its 0 point is also the 0 point in the coordinate system. So it's pretty easy for us to translate this whole thing to our liking. We'll translate it along the x-axis with trough, which results in it being centered in our piece. Then along the y-axis we'll give it 105 millimeters. So we have 5 millimeters of the part left behind it where our screw can go through. And let's translate it around the z-axis. Bang. And we can disable the visualization. That looks nice. It won't cut doesn't cut in here. There's still some millimeters left, so we just copy it, because I also want one in the top. Bang, and here we have our two bigger holes for the screwdriver. Now we want the smaller screw holes. We can just copy everything from above and just change the numbers up a little slightly. We want a radius of 3, and instead of 105 we just translate it by 99. I'll show you why. By just translating it 99 millimeters to the left, we still have 1 millimeter sticking out, which makes a clean cut through the surface, and we have our screw hole, which looks like this from the other side, and we have 5 millimeters of the part left in here, which should make for a pretty solid surface. And again, copy the second hole, change the radius, change the translation, and there we go. Now in between all of these changes I made in the code, I always hit F5 to just give it a quick render, and if you're ready to export it, you hit F6 once, which will give it a final rendering pass, and then you can just export it as STL. We'll export this as board holder single STL, and we can open this file in any slicer. I'll use Repetier. Okay, I loaded our part in repetier-host. It still looks the same. Now we just rotate it on this side, because all these layers will be along the gravity direction later on, this direction, which is now X, and so they will have the most strength along this direction actually, because the shell will be one part around this. So for this slice I wanted 3 outer layers, an infill of 20%, as you can see here, and you can do this on the printing and structures. I used 1.2 millimeters for the hull thickness, 0.9 millimeters for bottom and top thickness, and 15% infill overlap, which results in this. So the top and bottom thickness of 0.9 gives me 3 solid layers in the bottom and in the top, and in between it fills with 20% infill. Just what we wanted. And always remember, kids, it's not the infill that gives you the most strength in your part, but the number of outer layers that you have. So for this project I'm estimating that 3 outer layers in this size of a cube and 20% infill should be more than enough to hold these boards when they are wedged in here. Alright, let's put it on the printer. Doesn't this look awesome? I printed those two in PLA since they'll be mounted in the hallway. PLA has enough strength to hold these boards, and there'll be no weather and no UV light, so we should be good for a long time actually. Now let's drill some holes and get these mounted. So as you can see, everything went according to plan on the first try, which really scares me, so I probably hit some electrical pipe or something that will explode when I'm sleeping or whatever. But yeah, back to topic. I can take the skateboard out easily, I can go take a ride, I come home and put it back in here and everything's fine. Now in the next scene I'll show you how you can mount the camera to your skateboard. Alright, camera on the skateboard for some epic ego view shots. Now you could of course just drill a hole in this, put a screw in there, some camera mount screw or whatever. You could also 3D print it. There are some fixtures for longboards I've seen, or you could just glue something on there. But I don't like all of these solutions because either they're permanent and you have something in the way, and if you want to ride freely, that's a no-go. If you just put a screw in there, it might fall out, become loose, whatever. So instead I chose to put this little fella in here. This one has an outer thread which is 3/8 and an inner thread of 1/4 inch, I guess is the unit. Regular camera screws basically. This is made of metal, which is quite important because I'll melt these in. We are working with the plastic board after all, which is kind of cool. After that, I just put an adapter in there which has a quarter thread on one side, quarter thread on the other side, quarter screw, camera thread. Afterwards you can either directly screw your action cam. All of these have nearly all of these have this camera thread. You can either screw it on directly, which fits perfectly. Or if you want some more freedom to compose your shots, you can also get one of these little ball heads and screw that on here. Screw the little cam on top. Fix everything up and you're good to go. You can film this way, upwards, downwards, left, right, whatever you want. And I'm pretty sure that this ball head would even hold a DSLR, although I wouldn't skate with that on there. Or any other GoPro accessories or camera accessories, because all of them are pretty standardized and nearly all of them take these 1/4 screws. After this video I'll show you a short clip of me and my girlfriend riding in the park using the camera mounted to the board, as well as my new Mavic Air drone and some Galaxy S9 footage cut together in an epic and awesome feel-good clip. So today's episode was, at least for me, a pretty cool episode because of several reasons. 1, skateboards, 2, skateboard mounted cameras, and 3, 3D printing useful stuff. I mean, from idea to product it took nearly only 2 hours, I guess, and I didn't even have to leave the house. So designing the part in OpenSCAD took about 5 to 10 minutes, as you've seen. Printing it took another 2 to 3 hours, and then mounting it 5 minutes. And as always, if you enjoyed today's episode as much as I did, please consider leaving a like, subscribing to my channel, or leaving a comment with ideas, suggestions, or things you disliked about these videos. Thanks and bye bye.